This is the third video in the series of videos on pulleys. This video covers a third pulley example and discusses some of the finer points. So one of those points is getting the direction of acceleration correct, or what happens when you don't get that correct, and then solving simultaneous equations by elimination versus substitution. This was mentioned in an earlier video. The point would just be to prove that they come out the same way. You get the same answer from either method. So as per usual, the first thing to do is to make a picture that details all the information given in the question. So a light, inextensible string passes over a smooth fixed pulley. To one end, a mass of 3.2 kilograms is attached, and to the other a mass of 7 kilograms. Calculate the acceleration of the system. Well, step one is always just to draw the picture. So there's the pulley. The string hangs over either side. One mass is 3.2 kilograms. The other mass is 7 kilograms. Second step is always to add the forces. So as both of these objects have mass, they also have weight acting on them. 3.2 g for the one on the left and 7 g for the one on the right. They're both attached to a string, so they both have a tension acting on them. The tension is the same because the pulley is smooth. So that's step 2, adding in the forces. Step 3 is to put the acceleration arrow in. Here I'm going to not really think about which way it goes, so I'm just going to say that that the 7 kilogram mass accelerates up and the 3.2 kilogram mass accelerates down. One thing you do have to do is, if you say the one on the right goes up, then the one on the left has to go down. Or if you say the one on the left goes up, the one on the right has to go down. That's step 3 with the acceleration. Step 4 is to apply Newton's second law, F equals ma, to each object. So first we'll apply this to the 3.2 kilogram object. As it's accelerating down, we'll take down to be positive for that one. So we've got 3.2 g acting down, and then tension is acting up, which is negative in this scheme. And then that has to be equal to ma 3.2a. We also, still part of step 4, we apply F equals ma to the other object, the 7 kilogram mass. It accelerates up, so we take up to be positive. So that's tension, which is up, minus 7g, as weight acts down, equals 7a. Then we'll deal with this via elimination first. So here's equation 1, there's equation 2. You'll find again and again with these problems that if you add equations 1 and 2 together, you'll get rid of t, because one of them has t acting negatively and the other one has t acting positively. So when you add those together, you get a total of 10.2 g. No, you don't. You get minus 4.2 g on the left, and you get 10.2 a on the right. So then a is equal to 10.2 minus 4.2 divided by 10.2 minus 4.2 g divided by 10.2. And that is acceleration of minus 4.035 minus 4.02. The minus is important to think about. The minus means that we got the direction of acceleration wrong the first time we did this. So if you wanted to go back to the picture and put acceleration on, in the correct physical direction, it should look like those red arrows there. And then just to see that substitution would give exactly the same thing. So we'll make t the subject of equation 2. So t is equal to 7a plus 7g. We'll plug that into equation 1, 3.2g minus 7a plus 7g in brackets because it's the whole thing being subtracted. So then this leaves us with 3.2g minus 7g. That's again minus 4.2g minus 7a equals 3.2a. 10.2a on the right minus 4.2g on the left. This gives us the same thing, minus 4.02. That's it. Okay.